games go, because we're going to be playing tournaments against other students here at DSU. And as well as I've heard us talking about maybe doing some games against other schools, some tournaments there against other South Dakota universities. Whether or not you want to learn how to play, enjoy playing, or what you want, you can join using the links below, or just go to the first one, dsuchess.club, and click the join tab. The tournaments, I believe, will be hosted on Lichess, and then we'll be meeting in the Discord, so make sure that if you want to join, you join at least those two things. So yeah, sit there for a minute. All right, so back to computers and chess. All right, so chess has a kind of a long and interesting history on its own. For the most part, we're not really going to go over that because there's not a lot of computers back in the old days, So if you want to go out look into history, there's a lot of interesting stuff there. But the first bit of technology ever made was something called the Mechanical Turk, right? It was invented all the way back in 1770 by a diplomat/inventor, Wolfgang von Kempelen. Could be pronouncing his name wrong, but the device was kind of the first self-proclaimed mechanical chess playing machine. It was so surprising that, it got the attention of people like Benjamin Franklin and got them to go see it in action. However, if you look at the machine in the picture, you might notice that there's enough room to fit a person in that box. So it actually wasn't a mechanical machine playing moves based on what you played him on. They stuffed a person in there, and he's who you'd really be playing against. So it wasn't an actual chess machine, more so a trick. No one's really sure on his motives to doing such a thing, but it's pretty funny. So I guess you can't disrespect it too hard. But since it wasn't really a chess playing machine, why bring it up in the presentation? Well, it seems important to the history because it got people engaged in the idea of, can they make a machine that can play chess? Well, after this, there's a big kind of blank period where not a lot happens because computers aren't a thing yet. So we skip all the way up about 180 years ahead to the first attempt at a computers that play chess. Now, before this, there were plenty of computer scientists trying to work it out, and that would include Alan Turing himself. He had made an algorithm on paper that could play chess, but he would pretty much be making the moves and then going through the paper to decide how the moves make it, so it didn't really count. One of his colleagues, Dietrich Prince, actually did make a computer that could kind of play chess in the 1951. It couldn't actually play a full game of chess, but it could solve any position so long as it had force mate in 2. Most of the restrictions of this was due to memory and computational restrictions of computers at the time, as they were still very, very early on in the production. It was running on the Ferranti Mark I computer housed in Manchester, but even compared to 10 years in the future, it wasn't much as far as computation was concerned. But the fact that the algorithm worked in being able to spot mate in 2s was a huge step, as it was for most part the first step. Right. And then we have to go ahead and talk about Minimax algorithm. So the goal of this algorithm was to kind of try and maximize its own score while trying to minimize its opponent's score, which, how it got the name, minimize, maximize kind of thing. How exactly it determines or evaluates the position on the board isn't always, it's not as exact as pure calculation. A lot of it uses what's called heuristics, right? And that's just kind of like general rules of thumb of the game. For example, in chess, there's pieces, and if your piece can attack more squares than their piece, then your pieces could be considered better, right? And that's not always true in chess, all right? But, it kind of gets the idea. They're like generic rules that help you determine what is good. It might not always be the case, but it gets you in some direction. And if you put that in combination with the Minimax algorithm, it kind of allows you to start having something that can play chess. It's kind of been used as an essential tool in chess computers, and it still sees its use today. Alan Newell and Herbert Simon used it to develop the NSS program. The NSS program stands just for Newell, Simon, and Shaw. So the naming of the creators there. But what they did is they combined the Minimax algorithm with something called alpha beta pruning to speed up the search for moves by pretty much trying to reduce the bad moves, right? Or trying to reduce it seeing and calculating bad moves that there's no point in calculating. But yeah, once they've had this algorithm, they started in the 1960s developing computers that could actually play chess. Now, the type of AI labeled for playing chess was called cognitive simulation because it was because of the development is focused specifically on algorithms that could simulate some narrow aspect of human cognition rather than general intelligence. They developed the first computers to be able to play a full game of chess. And then by 1962, some MIT students developed a computer that could beat amateur level players. So if not professional level players, but it's getting there. It's getting to the point where it can actually beat somebody now. It's not just playing random moves. It knows how to play. And then 5 years later, in 1967, MIT programmer Richard Greenblatt got an unprecedented rating of 1400. Unprecedented for computers. For humans, that's still, it's about on the same level as a really good high school student. Not the best high school student, but a really good one. And the way he really achieved this is kind of by adding more of those heuristics, those rule of thumb kind of things, or improving upon the ones that already had. You'll see he's in the photo here. He's the one right next to the server to the left. But yeah. So now that we're starting to get into talking about the ELO rating of things, we should probably go through and just kind of give you a general sense of what that means. So scoring ELO, right? So the ELO system was kind of a rating system designed to compare chess players to each other. The system they used is called ELO, named after the inventor Arpad Elo, who himself was actually a master level chess player and an active member of the USCF, which stands for United States Chess Federation. He was kind of one of the founding members of that. And he developed the system for it, and the system isn't just used for chess. It's used for things like tennis, football, like sports, all over, games, video games. It's a pretty common system used, right? And the main idea behind it is that two players of equal rating should win about the same amount of games as each other over a long series of games. It's kind of like the statistical likelihood of flipping a coin. The more you flip it, the more it's going to reach 50-50. Players of the same rating or similar ratings should be closer to winning the right amount of games over a longer period of time. So it's like, two players of the same rating, one might win 3 games in a row, but over a long series of games, it'll get a lot closer. And then it's also designed so that a player with 100 more ELO points should win about 64% of the time, and a player with 200 more ELO points should win about 76% of the time, right? And you can gain points by winning, and when you lose points. The better the player you beat, the more points you get, and the less points you'd lose. And even draws, you can gain points if the player you're facing is high enough level or high enough rated themselves. So that's just, as I said, that's just kind of a basis because I know I'll make a few references to ratings, so it's probably best that you have at least a general idea of what's going on there. And this takes us up to the 1970s. So in the 1970s, chess playing machines kind of enjoyed a fairly steady increase in their ability the entire decade. It wasn't something super dramatic, but the constant increase of computational power predicted by Moore's law, as well as hardware designed specifically to search the internal computer representations of the game, which are known as the tree. So that's how the computers kind of represented themselves. It's kind of like a tree-shaped thing. but it gave them a hardware boost big enough that computers designed to play chess would actually be able to outplay big mainframes and the supercomputers at the time. So not only that, but at the same time, the addition of more effective heuristics and better searching techniques gave them a boost to software, right? The searching techniques played a particularly big role as it added iterative deepening, which would gradually increase the depth to which the computer calculated moves. Before, it would always be a set amount. It would always try and calculate 20 moves ahead and calculate every variation 20. But now it starts, one move ahead, two moves ahead, three moves ahead, and that helps it narrow down some moves that it doesn't have to calculate, and kind of makes the search go a lot quicker. And then in 1978, there was a famous chess match between international master David Levy versus Chess 4.7, which was the most powerful chess playing machine at the time. The match was arranged because David had claimed that no chess computer could beat him 10 years before. But 10 years after he had said that, it wasn't clear that was still the case, which led to the match being set up. Levy did end up winning the match 4.5 points to 1.5 points. But the fourth game of the match was the first time a computer had beaten a master in competitive play. So he'd won 4 games, lost 1 game, and drew 1 game. But that was right at the end of the 70s. So next came into the 1980s, right? And this is where people kind of really started to get to worry, about computers becoming better than humans at chess, or consider that computers could be. Computers were getting so widespread and popular that it wasn't a hard thing to find a computer that could play chess, right? And the introduction of personal computers like the Apple II or the Commodore PET gave any programmer the chance to develop a chess playing software, and that over time made it increasingly it added pretty much more ideas to the space, and it allowed more accurate and effective heuristics and another steady increase. Well, a little bit less steady. It's starting to get a bit exponential now, but chess playing systems became a standalone thing you could buy too, a computer specifically designed to play chess pretty much. One of the more common ones was the Chess Challenger by Fidelity, although it was only able to play at an amateur level, so just like some of the first chess playing computers. But now this is open to the public. You can go out and pick and actually buy a chess playing system. But more importantly to the development of chess playing machines was the introduction of the first microcomputer chess championship, which also in turn led the USCF to ban the use of computers, except when they were represented by the chess systems creators themselves. So like IBM could go and they'd be like, we have this chess system, and they could play in a USCF tournament, just to get kind of an idea of what their rating was, I suppose. But yeah, you wouldn't be able to use a chess to help you play chess, or a computer to help you play chess. And then perhaps even bigger still was the introduction of the Fredkin Prize, which would reward any computer that could beat the reigning world chess champion in a chess match with $100,000. This ended up kind of leading to the development of the computer Deep Thought. It was a computer. The computer's name itself was named after the supercomputer in Hitchhiker's Guide to the Galaxy. So if you're a fan of that, then that's where he got its name from. It was the first computer to reach the Grandmaster rating of 2400, and it did so in 1989. So right at the very end of the decade. It was set to play the World Chess Championship, or World Chess Champion at the time, Garry Kasparov. I've also heard him called Kasparov, so however you want to pronounce it. But it was set to face him in a couple of exhibition matches. It lost these matches convincingly, as top human chess players seemed to still hold the advantage, but at the same time, many other computers soon followed in hitting Grandmaster level rating of 2400. And so it almost felt guaranteed at this point that eventually we'll have chess computers that can play a higher level than even the best players in the world. And well, that's kind of exactly what happened. This kind of kept building up to the point of Deep Blue versus Garry Kasparov. And this was kind of one of the most famous events in chess history. I'm not sure how it ranks as far as computer history goes, but I would say it's still a pretty big one. So, Deep Thought, which was the computer from 79, or sorry, from 89, was got bought out by IBM. And IBM decided that they were going to put a team together to take this machine, and the goal, and their only goal, was to beat Kasparov. And then they renamed it to Deep Blue. They gave it a huge software and hardware boost, right? And just kind of like help you understand what kind of thing like Kasparov was facing. Like, it's important to note that Deep Blue can evaluate 200 million chess positions per second. So 200 million, right? I think on like a modern computer, like Stockfish typically only runs through 70 million, although it doesn't have to run through as many. But we'll talk about Stockfish a little bit later. Not a whole lot, but the match itself took place in May of 1997, 8 years after the exhibition games against Deep Thought. There weren't too many big things that happened in the 90s except for this match, or at least in comparison to this match. The games were played in a small television studio in the Equitable Center in New York City, where all 500 seats got sold out every single game. Now, it was a smaller venue, but it was televised as well. So there was also people watching around the world, but the seats in the studio were always sold out. Which is a funny thing. You don't hear that too often when it comes to chess. So we won't go too specific into too much details on the match itself. It is a really great match. It really is worth watching and getting the context for. But especially if you're interested in chess and stuff like that and computers. But there's a few things that happened that were, funny enough that I think they're worth noting. In game 2, Kasparov actually accused Deep Blue of cheating, saying that it knew the position beforehand and resigned that position, even though he had a draw with a perpetual check. He must have been too flustered to see it, I suppose. But it does feel a little bit weird to kind of think about how a computer could cheat when, at the time there weren't like better computers he could be using to cheat with. But, it was one of those moments that the rest of the match he kind of played a bit tilted, as it were. And but in the end, he did lose the match with a score of 2.5 to 3.5. He won one game, lost two, and they drew the other three. And then after the match, he seemed a full believer in the power of chess computers, right? Because he was quoted saying, in certain kinds of positions, it sees so deeply that it plays like a god. He was very much kind of, I guess, pessimistic on his chances of actually being able to beat something like this, at least in the future. He did eventually ask for a rematch, but IBM turned him down, and they retired Deep Blue, and it's still now being displayed at the Smithsonian Institute. So you can always go see it. I was always kind of curious to see what a rematch like that would have looked like, because some of his games did seem like he was not playing at his best. But he did play a couple of different chess engines later, and both of those matches ended in a draw. So they were not Deep Blue. As said before, Deep Blue kind of got retired immediately, and so he never got the chance to face that again. But this is going to kind of bring us back to modern chess computers, how they operate. So there's still a lot of chess machines, and most of them there's still a lot of chess machines that are playing like the old way, the whole development from the 60s to the 70s to the 80s, using the Minimax algorithm, alpha beta pruning heuristics, and it's just using more effective heuristics and more of them in general, in combination with better hardware, and to more or less brute force, chess. The most popular and powerful of them being Stockfish, which is an open source chess engine used by pretty much everything. It's the top rated chess engine, and it's free, so you can go and get it anywhere. So I mean, it's kind of just like a no-brainer if you were looking to find a chess engine. But there is kind of a new, well, there's a different kind of AI that kind of emerged over the past 5-10 years. An artificial intelligence research company known as DeepMind developed a chess AI known as AlphaZero, and they kind of released like a demo of that in 2017. AlphaZero playing chess. It learns how to play chess solely on kind of like playing it itself, and then using that to train its neural networks how to play chess. So it crams as many games as it can through itself, which for a computer is a lot faster than humans can, and it learns chess that way. So then the next question is, how does this compare to the older method of doing it, the kind of brute force minimax style of chess engines? And well, there was a match done with AlphaZero where it played in a 1,000-game match against Stockfish version 8, and AlphaZero won 155 of the games, only lost 6, and then they drew 839 of the games. Now, there is some debate as to how it would compare to current versions of Stockfish, which is version 10, because after this match, AlphaZero, kind of like Deep Blue, it's kind of, I guess I don't know if it's officially retired, but you can't go out and play against it if you wanted to. But the newest version of Stockfish is rated about 150 points higher than the version that AlphaZero played, whereas AlphaZero was rated about 50 points higher. So most people anticipate that Stockfish has kind of recrowned itself as the best chess engine. But since AlphaZero did kind of go away and kind of, well, it's never used anymore, because the code was never released or anything like that. It was never made publicly available. The chess community came together, inspired by it, and they made something called Leela Chess, or Leela Zero. I believe it's Leela Zero Alpha is the full name of it. But that's kind of like a more a community-based thing that uses all the same techniques as AlphaZero. I think in the last chess tournament, it was like the 3rd ranked overall, and Stockfish is still rated number 1 at like 3,700 rating, which is absolutely insane because no human chess players even broken 2,900, I don't think, or maybe 29. They certainly haven't broken 3,000. But so it's gotten to the point where chess engines, regardless of what algorithms they're using, whether it's the Minimax or the new neural network kind of stuff, like there are significantly better than human players. But the good news for us human chess players is that we have computers have given us plenty of other advantages to chess, or advantages to learning how to play chess. Chess playing computers aren't the only thing that's had a huge impact. Things like the internet, allow us to play with each other, especially, times like this, COVID, join the DSU chess club, and can allow players to play chess against each other from around the world as well. It has helped getting, it has made getting/teaching lessons easier, as well as allowed for the development of programs to help with things like tactics training, which is one of the most important things you can do when learning to play chess. It has also helped make the community bigger through things like Twitch and YouTube. There's used to be more restrictions on what it would take to watch chess. I mean, chess wouldn't normally be televised, but now you can go anywhere you want and still watch it. And so most of this conversation has been chess AI. The relationship between computers and chess does go further than that, at least on the chess side of things. So yeah, it is also worth noting that the future of chess AI, although it's not clear, because as I said, Stockfish did kind of retake its crown, people generally seem to agree that the ideal would be some combination of the old method versus the new method. So it would be something along the lines of something that uses neural networks, but also uses the old Minimax and heuristics kind of strategy to kind of narrow down what even that would search. So I mean, it's an exciting world. We'll see how chess engines end up. Then, yeah, I think that is it for the presentation. I should probably go back to this. So make sure, I mean, if you're interested in chess at all, to join the DSU Chess Club, dsuchess.club. You can find the rest of the links in the join tab there every Thursday at 4. And yeah, come play some chess.